Hi, fifth graders. So this is a different assignment. We haven't done this during distance learning. This is a book, and at school I have about 38 of them, I think I counted, which was not quite enough, one for every fifth grader. So I did not send it home to you. But what I can do is I can take some pictures of the story I'll read you today, and you can read the story yourself or follow along with me. And this is about Galileo Galilei, swinging through history. What do grandfather clocks have in common with children on swings? Pendulums. A pendulum is a mass. Mass is like a science word for weight. They're a little different. We can talk more later about that. So, a pendulum is a mass that hangs down from a rope, chain, or other support. When the mass is moved from its resting position and then released, resting just means where you hold it before you let go. All right, so in its resting position and then released, the pendulum swings back and forth. The movement is called oscillation, fancy word. Each swing takes the same length of time to complete until the pendulum runs out of energy and stops. The longer the pendulum, the fewer swings it makes in a given length of time. Pendulums were first recognized by the Italian physicist and astronomer Galileo Galilei. That's a drawing of Galileo. We don't have photographs of him. He's a really old dude. Okay? Yeah. He was alive in 1564 to 1642. Told you. He was been dead a long time. Really old dude. Galileo saw a chandelier swinging from a ceiling like a pendulum. He had no way to measure how long each swing of the pendulum took. He used the rhythm of his own pulse to time the cycles. He figured out that the time it took for a pendulum to swing back and forth was always the same, no matter how far it was swinging. All right, one, he used his own pulse. So he had to have his pulse measured to time it because there was no stopwatches. This is like back in the 1500s. No stopwatches, probably the 1600s. He was a kid in the 1500s. All right, and next up, right, you thought it was hard to time your pendulum, like to hold your stopwatch and let go of the pendulum at the same time? He had to measure his pulse to time it. But Galileo, he was an amazing guy, almost as amazing as you fifth graders. All right, back to this. He had no way to measure how long each swing of the pendulum took, so he took the rhythm of his own pulse. Galileo thought that a pendulum could be used in timekeeping, but it was a Dutch scientist, Christian Huygens, who was alive from 1629 to 1695, so he overlapped with Galileo in life, who put this idea into action. And can you see the picture? That's Galileo's pendulum from the 1650. All right. Huygens was an astronomer. He needed a way to measure time as he observed the sky. Galileo was also an astronomer. He was kind of a scientist of all things, but a lot of physics, a lot of astronomy, stars, outer space. Galileo discovered there were moons around Jupiter. Yes, he was the very first person to discover it and write about it. So, sometime around 1655, Huygens created the first reliable clock that measured seconds accurately. He used a pendulum to regulate the movement of the clock. In 1673, Huygens published a book that explained how the length of a pendulum determined the time it took to swing back and forth. Perhaps the most common use of pendulums today is the grandfather clocks. Most of these clocks are powered by the movement of a pendulum. A grandfather clock keeps time by using a mechanism called an escapement. The escapement regulates the release of the mass's energy. It does this by transferring that energy to gears that move wheels on the face of the clock. I'll move the picture closer for you. It's hard to get the picture close and read it. Okay? And as the pendulum swings back and forth, the escapement gears move. So do the clock's hands, 1 second at a time. The only problem with this system is that the pendulum eventually runs out of energy. It moves slower, then finally stops. That is why grandfather clocks need to have their masses reset on a regular basis. More energy must be provided to the pendulum to start the process over again. You can be a pendulum too. Next time you are on a swing, think about how your body moves through the air. You are swinging the same way a pendulum does. The energy to keep yourself moving comes from someone pushing you. The harder you are pushed, the higher and faster you swing. So there you go. All of your science about pendulums this week is the same science Galileo did, measuring his pulse and to figure out the very first clocks. So your science is the basics of all of our clocks that we have now. Great work learning this week.